Good evening, students. In today's lecture, we are going to discuss JW NEET numericals from the topic states of matter. So, question number 1 to 10 we can solve today. First question: a gas of volume 2000 ml is kept in a vessel at pressure 10 to the power of 3 Pascal at 27 degrees Celsius temperature. If pressure is increased to 10 power 5 Pascal at same temperature, what will be your volume of gas? Now here an important term called as same temperature. So let's solve this. V1 is 2000 ml and pressure P1 is 10 power 3 Pascal. Now temperature they maintained constant. Let us write temperature is constant, nothing but 27 degrees plus 273 Kelvin. Now if you observe here, they are asking find out the final volume if P2 is 10 to the power of 5 Pascal. You know this, if you are maintaining temperature as constant, what will happen? The volume is inversely proportional to pressure. So we can take it as PV constant. So the formula is P1 V1 is equal to P2 V2. Now substitute that. What is P1? 10 to the power of 3. V1 is 2000 ml. Now here P2 is 10 to the power of 5 Pascal and V2 we need to calculate. Send this to other side. What we will get? 10 power 3 into 2000 by 10 to the power of 5. So we can cancel like this, 10 square. Now here cancel 100. What you get? V2 is equal to 20 ml. Hope you have understood this. Now Boyle's law we have used here. So answer is B, 20 ml. Now observe the second question. At given temperature and pressure, you have 20 ml of gas. Now they have given a term here, diffusion. So we are applying Graham's law of diffusion in this question. You can try to solve the question. So what is mentioned here? V1 is equal to 20 ml. Diffuse through porous membrane and time is given as 5 seconds. What they have mentioned is find the volume of CO2 and the time taken by CO2 to diffuse is 10 seconds, and they have mentioned the vapor density of gas is 11. So if they give you vapor density, what you need to calculate? Molecular mass. What is the molecular mass? 2 into vapor density, nothing but 2 into 11, you will get 22. And we know what is the molecular mass of CO2? 44. Using this, we can apply Graham's law of diffusion. R1 by R2 is equal to root of M2 by M1. Now you can calculate what is rate. Rate is nothing but the volume divided by time. So how to do that? Let us calculate here. R1 is V1 by T1, 20 by 5. You get 4 meter per second. Second one, the rate, second rate R, the rate of diffusion of carbon dioxide is equal to, we need to find out V divided by time is 10. Hope you have understood this. Now substitute this in this equation. What we get? R1 is 4 divided by volume of CO2 by 10 is equal to root of molecular mass of CO2, that is M2 is nothing but 44, M1 is 22. So root 2 here you will get. Send this to other side. What we get? 4 by root 2. This one is equal to volume of CO2 by 10. Now what we get? 4 into 10, nothing but 40. 40 by root 2 is equal to volume of CO2. Hope you have understood this. So 40 by root 2. This is your answer. Copy the solutions and we'll move to question number 3. Now let us see question number 3 and 4. In 3 they gave 1000 ml of gas at 600 torr pressure and 500 ml of gas B at 800 torr are mixed in 2 liter flask. So if you are taking a flask, nothing but 2 liter or 2000 ml, in that you are having A and B are mixed together. The question is what will be the pressure of the mixture. So let us write the first one. Pressure of A 600 torr and volume of A 1000 ml. Now pressure of B is 800 torr and volume of B is 500 ml. Now if you consider P and V as the mixture, so pressure we need to find out and volume is 2 liters, nothing but 2000 ml. Now apply the formula. We can write it as PV is equal to PAVA plus PBVB. This is our formula. Now we want the P, so send this to other side. What you get? PA how much? 600 into volume is 1000 plus PB is 800 into volume 500 ml divided by 2000 ml. So the volume of the flask. Now we can write like this: 6 into 10 to the power of 5 plus 8 5 is 40. So we take it as 4 into 10 to the power of 5 divided by 2 into 10 cube. So to calculate easily, we have converted like this. Now this will become 10 into 10 to the power of 5 by 2 into 10 cube. We can cancel this like this, 10 square. This will become 5. So answer is 500 torr. So this is your answer. Hope you have understood this very simple calculation. Now coming to the fourth question, average kinetic energy of one molecule of an ideal gas at 27 degrees Celsius and 1 atmospheric pressure we have to find out. This was asked in Engineering and Medical Common Entrance Test 2009. So what is the formula for average kinetic energy? So the formula average kinetic energy Ek is equal to 3 by 2 kT. Now what is K here? K is nothing but Boltzmann constant and the value is 1.38 into 10 to the power of minus 23 joule per Kelvin per molecule. So this is the constant which we should know. And what is T here? T is temperature. How much they have given? 27 degrees plus 273, nothing but 300 Kelvin. Now substitute the values to get your answer. Average kinetic energy Ek is equal to 3 by 2 into Boltzmann constant into temperature. So let's cancel 2 and 150. So 450 into 1.38 into 10 to the power of minus 23. So I have calculated this earlier, so I got 621 into 10 power minus 23, but here it is in 10 power minus 21. So converting that, I get 6.21 into 10 to the power of minus 21 joule per Kelvin per molecule. So answer is B. Copy down the solution and let's move to question number 5. Now let us solve 5 and 6. Fifth one, what is the temperature at which kinetic energy of 0.3 moles helium is equal to kinetic energy of 0.0 moles of argon at 400 Kelvin? It was asked in MSET 2008. Now, number of moles into temperature we can write like this. N1 T1 is equal to N2 T2. So consider this as helium and this is argon and substitute the values. 0.3 and they are asking to find out the T1 is equal to number of moles of argon 0.4 and temperature is 400 Kelvin. To find T1, send this to other side. So 0.4 into 400 by 0.3. So we can take it as 1600 by 3. Nothing but 35. So 533 Kelvin. So answer is C. So hope you have understood. Very simple. Number of moles into temperature you can get. This is for helium and this is for argon. Hope you have understood this. Next one. They have given at 400 Kelvin temperature and 0.08 to 1 atmosphere pressure. Find the density of CO2 in gram per liter. This was asked in medical exam 02. Now we have derived the formula of density. What is that? Pressure into molecular mass by R into T. So applying this, what is the pressure given? 0.0821 atmosphere. Molecular mass of CO2 we know that is 44. R is 0.0821 and temperature they have given as 400 Kelvin. Now on substitution, what we get? 0.0821 into 44 by R 0.0821 into 400 Kelvin. We can cancel this now with 411 by 100, nothing but 0.11 gram per liter. So density 0.11 gram per liter. So copy the solution. So in this class we have completed up to question number 6. We can continue from question number 7 in the next class. Hope you have understood this. Thank you so much.